I feel like these hormones were covered really well and explained really well, but thought I'd just kind of put a video together to maybe put it a different way in case anybody wanted it. So our pituitary hormones, I think the most important thing about this is to remember that they call it an axis, or the three ring triad, I've also seen it called. But the thing about this is that in this kind of whole get up with our regulation of our body, there's going to be our sensor, there's going to be our master gland, which is going to tell things to do something, tell things in the body to do something. It's going to release a hormone that's going to do that. And then we're going to have our secondary glands or effector organs that are going to be stimulated by that hormone from the pituitary. Okay, so the pituitary is adequately called the master gland because it kind of controls everything in the body. Yeah, it really does. It's kind of cool. So our hypothalamus is our master. If this is the master gland, this is the headmaster. So it's like the the superintendent of the school district, right? So the hypothalamus lets the pituitary gland know what it can and can't do. This gland has some autonomy, as we're going to see. It's going to be under some different kinds of regulation that don't actually go to the hypothalamus, but the hypothalamus in the end gets the final say on what happens to it, right? So our hypothalamus is going to sense deviations in the homeostasis of the body, okay? And it's going to regulate those by the use of telling the pituitary gland to secrete something or to not secrete something. Okay, so the hypothalamus, for example, can sense the osmolarity of our plasma, like in our blood or in our extracellular fluid, and it can tell if that is outside of homeostatic range, so we can inhibit or increase the amount of antidiuretic hormone being released by the posterior pituitary gland. And that, in turn, is going to act on the kidneys to regulate whether we have aquaporins being added or taken away from the collecting duct, which is going to, in turn, affect how much water we reabsorb. And we're going to increase or decrease our osmolarity. So, big, long arc, but it always brings us back to a homeostatic point. That's the important thing to remember. All right, so like I said, like I always say, always remember the big picture, right? Work big to small, all right? So with each of these hormones, remember like the overarching theme or goal of what that hormone does, okay? And then you can think of individual examples of the way it might affect a certain part of the body. All right, so the hypothalamus, we said, regulates what the pituitary gland does or doesn't do. There's two different parts of the pituitary gland that are kind of influenced by the hypothalamus in different ways. So you have the posterior and anterior pituitary gland, thus named because one's forward and one's back with respect to our brain and our midline. So if we look at the posterior part of the pituitary gland, I kind of drew in here, not very well, I'm not an artistic, right? These long neurons that come from the hypothalamus and their axons travel all the way through down to the posterior pituitary gland. And then we see we've got an axon terminus right here, right? So we know that from our previous lectures on neural tissue that hormones or neurotransmitters are going to be synthesized in the cell body, passed down an axon, and then they're going to be packaged into a vesicle down here, and they're going to await the signal, which is a depolarization, to be able to release into the bloodstream. And since it's a hormone, it's going to be traveling in the bloodstream, okay? So there's only 2 hormones that work like this. And if we can remember these 2, we don't have to remember the anterior pituitary gland hormones. Because by process of elimination, if you get asked like a question like, which one of these is a posterior pituitary gland? Well, you know the 2 already. If they ask you what your anterior pituitary glands are, hormones are, well, we can automatically rule out these 2. That means anything left has to be an anterior pituitary hormone, right? So you don't have to remember these if you can just remember these 2. That's my point, all right? So that's the way the posterior pituitary gland is controlled. What about the anterior pituitary? Well, the anterior pituitary is a little different. So I tried to use a different color here to signify that this is not an axon like the posterior is. It's a capillary. So there's capillaries and there's cells up here in the hypothalamus that are going to release another hormone, if you can believe it. It's like, why don't they just make the hormone themselves instead of having the anterior pituitary gland make one and secrete it? I don't have an answer for that, but this is just the way the body does it. So we don't question the body, right? Because it's amazing. So there's going to be a hormone secreted in the hypothalamus when we deviate from a set point. And that is going to be released into these capillaries, which is going to kind of percolate or flow down into the anterior pituitary, and they're going to stimulate the cells of the anterior pituitary to secrete their individual hormone or the specific hormone that they're releasing. So what these hormones are called from the hypothalamus are called releasing hormones. I got it kind of right here on the side. Releasing hormones are they're just a fancy word for a hormone made in the hypothalamus that's going to cause a specific hormone to be released in the anterior pituitary. Simple enough, right? Okay, so an example of a releasing hormone would be like prolactonin. Prolactonin is the releasing hormone for it is just going to be called releasing hormone. Okay? And then each of these is just going to be put an R in it if it's a releasing hormone. So like gonadotropin hormone or growth hormone, excuse me, growth factor releasing hormone is going to be released by the hypothalamus in order for the anterior pituitary to release these ones. So when that comes down and flows through our capillaries here, it's going to find receptors on our pituitary, our anterior pituitary cells that make growth hormone, and when it binds, it's going to stimulate this growth hormone to be released or exocytized from that cell and be put into the bloodstream. And that's going to happen with all these anterior pituitary gland hormones. All right? So I think that the way they're going to do this is we're going to go through each of these hormones and their effects on the body and their targets in turn. But in the first lecture there, we started on some basic ones, or our posterior ones, and then a couple of our anterior ones. So our posterior ones, I said, were oxytocin and antidiuretic hormone, okay? So oxytocin, we always got to keep in mind the major overview arching theme of our hormone when we're talking about these, right? So big picture, what does oxytocin do? It's primarily going to be present in labor. So it's going to stimulate uterine contraction. So this is our labor hormone. That's what I call it. And it's also going to synthesis or increase the synthesis of prostaglandins. So oxytocin levels are normally pretty low, and it's worth mentioning that we don't know what this hormone does in males. Still don't. Kind of a mystery, but in females it's going to increase in levels, and it's going to be under a positive feedback loop. So positive meaning we're going to drive the process to completion, so we're going to keep increasing these levels of hormone until the process is done. In this case it's labor, so it would make sense that oxytocin levels are going to increase the farther a woman gets along in labor. And finally, when she gives birth, then the oxytocin levels are going to fall again, so that we can return to our set point, as you say. So oxytocin is that. There's a synthetic form of oxytocin called Pitocin that they give to mothers who are their due date, they've gone over their due date, and baby's like, oh no, not yet, I'm having a good time here. They'll give them Pitocin, and that can induce or start labor. Okay? Alright, so we also have the antidiuretic hormone. So antidiuretic hormone we really covered extensively in the kidney lectures, but I think that it's a good idea to just briefly mention the mechanism that it works on the kidneys. Okay? So what does antidiuretic hormone do? The way I remember this is I remember what diuretics do. So Lasix, one of the most common drugs in America, that's going to make you pee out water, right? So what's the anti of that, or the opposite of that? Well, we're going to increase our water reabsorption. We're not going to make as much pee. All right, so antidiuretic hormone increases water reabsorption. And it does this by a specific way. We always got to remember what part of the nephron it works on. It works on the collecting duct, and in the collecting duct, we know that it works on aquaporins from that other lecture, but he goes into a little bit more detail here and says that aquaporin 2 it's going to specifically act on, and that is going to be in our tubular cells, and it's going to be hanging out in the cytoplasm. And when ADH is bound to a receptor on our cell, it's going to induce the translocation of that to our tubular lumen side of our nephron, or our collecting duct, excuse me. So that's the way that works. It's worth noting that aquaporins 3 and 4 are on the capillary side, and they are present regardless of the amount of antidiuretic hormone that's in the kidney. Okay? Alright, so we talked about neurogenic versus nephrogenic diabetes insipidus. So neurogenic is going to be influenced by our hypothalamus, and this is going to be a failure. Let me get out of the way here. This is going to be a failure of our hypothalamus to adequately recognize the osmolarity of our plasma in the hypothalamus. All right, so let's see here. Let me look at my notes. All right, so we're either going to have neurogenic or nephrogenic. What's the way we can tell? I think this is the most important thing that he's getting at as I look back through my notes here. So neurogenic is going to be the way we can kind of differentiate the two is neurogenic is characterized by the hypothalamus not sensing the correct osmolarity of the plasma within it. Neurogenic is characterized by the kidney being unable to respond to antidiuretic hormone. So in neurogenic diabetes insipidus, the hypothalamus is secreting ADH like crazy, but we're not getting any response from the kidneys. So the kidneys are just flushing out water like crazy because no aquaporin 2 can be translocated to our tubular lumen side of our collecting duct, so no water gets reabsorbed, and we're just making tons and tons of dilute urine, and it's going to dehydrate us. So people with this have an excessive amount of thirst. So what's the two ways we can differentiate the two? We need to look at the antidiuretic hormone levels in a person. So we can test these, pull a blood draw, and see what the levels are. So if we have a high level of ADH, an extremely high level of ADH, and we're making a lot of dilute urine, so we got really clear urine, that's obviously going to be a problem in the nephron of the kidney. So the receptors in the kidney are going to be failing to respond to the antidiuretic hormone. And that's why we're increasing the levels, because the hypothalamus can sense that, hey, we're kind of drying out here, what the heck? And it's going like crazy, telling the antidiuretic hormone, you know, kick the kidney's butt, we need to increase our reabsorption of water, we're drying out. But the kidney never kind of gets the message because it doesn't have the receptor. Neurogenic, we're going to have inappropriate levels of antidiuretic hormone. So this is gonna not be secreted when plasma osmolarity is high. All right. Okay, so there's that. So we got procalcitonin. This was kind of the first anterior pituitary gland hormone that we talked about. It is characterized by, it's another kind of, I kind of deal with it or say it as a reproductive hormone for certain circumstances. But it's going to, basically the only thing that it really kind of induces a change in is lactation. So this is a really big hormone in lactating women. And I have a really good example for this that I'll get to here about oops kids. But it's under specific regulation, and it's going to induce lactation and sustain lactation in women, okay? Sometimes in men too, if we have a different endocrine pathology going on, right? Steroids, that'll do it. So this is under negative regulation by dopamine. It's under positive regulation by thyroid releasing hormone, or TRH, and it's under positive regulation by estrogen. So high levels of estrogen are going to induce secretion of this prolactonin, okay? And it's also the levels of this, if we increase the level of prolactonin, we're going to inhibit gonadotropin releasing hormone. So gonadotropin releasing or gonadotropin hormone is going to be our primary releaser for, it's going to induce formation of the gametes. So formation of sperm or releasing of an egg, okay? So if we release that, we're going to decrease our fertility in both males and females, right? So this is the reason that, you know, that I always go back to this hormone. I always go back to the example for whatever reason it sticks in my head. I don't know, real world examples always stick in my head. I don't know if they will for you, but, or whoever's watching this video, but hopefully they will. But I always go back to this thing of oops kids. Like a lot of new mothers, they go to like their baby classes or birthing classes. A lot of families kind of choose to do that to know what to expect during it. And a common thing, and you can look it up on the internet too, they'll probably tell you this on WebMD, is that breastfeeding, if you're breastfeeding, it's kind of like a natural birth control, right? So when you're breastfeeding, your levels of prolactonin are high, and thus your fertility levels are decreased in a woman. So prolactonin, a stimulus for release of prolactonin is suckling of the breast, and as long as that stimulus is coming in, we're going to keep increasing our levels of prolactonin. So as long as a woman's breastfeeding, by theory, prolactonin levels will be high, and thus we're going to inhibit our gonadotropin releasing hormone, so we're going to decrease fertility because we're going to not be ovulating at that point, right? Well, in real life, it doesn't always happen like this, and some women still ovulate even though they are breastfeeding, and then, you know, you get an oops kid, right? So yeah, no hating on oops kids. I was an oops kid, you know. So there's that. Growth hormone. Growth hormone is our primary anabolic hormone. So That's the way I like to think about it. Like I said,